Hello everyone, and thanks for jumping back into Kasimaths. Today we are going to be looking at area of sectors and arc length, a very common theme in the GCSE paper. As always, this will be broken down into parts where I demonstrate the concept first, then you have the opportunity to check your understanding, and to finish you will have one last independent task opportunity to ensure you check out with a secure understanding. So let's go ahead and jump in. Circles, sectors and arcs are a tricky part of the GCSE Maths exam. The formulae, although given in the exam, remain difficult to apply accurately in context, not even mentioning the vocabulary of radius, diameter, sector and arc. In this lesson, we'll look at area of a sector and length of an arc in the specific cases where the angles are factors of a full turn, 360 degrees. This is for you to build a solid conceptual understanding before using the generic formula given in schools. We'll be using the formula for the area of a circle, pi times r squared, and the circumference of a circle, pi times d. In case you're wondering what pi is, to keep this very simple, we'll say that pi represents a number roughly equal to 3. A quick reminder that a radius of a circle is a line segment joining from the center to any point on the circumference, whereas the diameter is a line segment joining 2 points on the circumference and going through the center. We have therefore the diameter equals twice the radius, or the radius is half the diameter. On the left we have the sector OAB, and we want to calculate its area. This sector has an angle of 40 degrees. We know that a full turn is 360 degrees. And how many times does 40 go into 360? Well, I have listed on the side, as you can see, the factors of 360. And we can see that 40 goes exactly 9 times into 360. In other words, we would make up the whole circle with exactly 9 of these sectors. The strategy, therefore, is to calculate the area of the whole circle and then simply divide by 9. The area of a circle is pi times r squared, as stated earlier. Now let's substitute the radius, here 18, into the formula. We get pi times 18 squared. Now watch out for this common mistake of thinking 18 squared is 18 times 2. It's actually 18 times 18. The area of the whole circle is 324 pi. We divide by 9 and we get 36 pi for the sector. We wanted the area in terms of pi here, so no need to use the calculator and find the answer as a decimal. However, let's not forget the unit. Since the radius was expressed in centimeters, we will use centimeters squared for the unit of area. On the right side, we have a sector angle 60 degrees, of which we want to find the area, once again, correct to 1 decimal place. A full turn is 360 degrees, and 60 goes exactly 6 times into 360. We will then calculate the area of the full circle. The radius in this case is 12 centimeters, so we write pi times 12 squared, which is equal to 144 pi. When we divide by 6, and we get our answer. Now in the question they want the area correct to 1 decimal place, and this is where we enter the whole calculation in our calculator and round it to 1 dp. That would give us 75.4. Once again, the radius was in centimeter. The appropriate unit of area therefore would be centimeter squared. Alright, time for a quick check. On your screen, the sector MIT, of which we want to calculate the area, correct to 2 decimal places. Press pause, take a pen and paper, and give it a go. Once you have the answer, write A, B, or C in the comment section below, then press play to move on to arcs and arc lengths. Here we have the sector SIC, and in this case we want to find the length of the arc IC. Now an arc is a part of the circumference. The arc IC here is the curved portion of the circumference highlighted in green. Since 45 degrees goes exactly 8 times into 360, we will calculate the whole circumference and then divide our answer by 8. Before using the formula pi times d though, we ought to be careful, as 12 centimeters here is clearly the radius of that circle. However, it is the diameter we need for the formula. As the diameter is twice the radius, we are simply going to multiply 12 by 2, which gives us 24. We apply the formula and we write pi times 24 for the full circumference. Then we divide by 8 and we get 3 pi. So we're talking about length here, not surface. We'll therefore keep centimeters as unit. Now, what if we wanted the perimeter of that sector SIC? The total length around the shape SIC. Well, the sector SIC itself is made of the arc IC in green and the 2 radii SI and SC. We would only need to add 2 radii to 3 pi to get the perimeter of the sector SIC as follows. And we'd get 3 pi plus 24. Watch out not to collect the lots of pi and the constant 12 or 24, as they are considered unlike terms. We'd simply keep 3 pi at 24. Time for another quick check. Pause the video, take a pen and paper, and have a go at finding the length of the arc PQ in terms of pi. If you feel confident, try finding the perimeter of the sector OPQ. When you're ready, press play to check your answers. And here are the solutions. And your turn now. On your screen, 2 final questions for you to attempt and make sure you got it. One on arc length and the other on area of a sector. Press pause to give it a go, then play when you're ready to check your answers. And here are the solutions. Alright folks, I hope you had a lot of fun navigating sectors and arc with me today and feel now more comfortable with them. If you liked the content, give the video a thumbs up and subscribe to the channel. Hit the bell so you get notified when new content is available. Thanks for watching everybody, and see you in the next.